Now, if I go over to Moodle, and you may or may not have noticed there's a new section here called bundling. And that's what I want to look at today. And next week's lab will be on this topic. And it is actually, it's mentioned in the assignment specification as well. It's not a big part of it by any means, but it is included in there. I guess the two main parts of the assignment, as you know, are E2E testing and the continuous integration pipeline as well. Anyway, so the slides that I want to go through today are these slides here. So the title is Webpack. Webpack is just a tool, as it turns out, and it is a bundling tool, or more generally, it would be classified as a build tool for web app development. Now, you might remember when I was talking about CI/CD, albeit 2 weeks ago now at this stage, one of the not one of really, but typically the first stage, or certainly an early stage in a CI/CD pipeline, is the build stage. And it was kind of difficult maybe to make sense of what we meant by build back then, but certainly after today's lecture, the notion of a build stage in a CI pipeline will make a lot more sense, because that's essentially what we're talking about. So this tool called Webpack is a build tool for web development. It's not necessarily the best tool, but it's the one that you use in the Web App Dev 2 module. For a number of years, Webpack was the only one, so it was certainly the leader in the market, but there are other tools out there now that are equally as good and arguably better. Although Webpack is going through a bit of a rewrite, as far as I know. So the rewrite of it may indeed bring it back up the charts, if you like, so to speak, in this whole area. So as I kind of mentioned there, so in the Web App Dev module, you're using a tool called Create React App. As far as I'm aware, you're still using that tool anyway. It was certainly used last year. And the Create React App tool uses Webpack internally. So that's why I'm covering it in this module. And in this slide, the screenshot that you're looking at, essentially, when you run the npm build command, is it mentioned there? Yeah, if I, sorry, if I just bring in my pen. When you run this command from the command line within a React application or React project, and in particular a React project that is developed using the Create React App tool, when you type that command and hit return, what it does is it creates a build folder in your project. And essentially what happens behind the scenes is that, well, if we kind of follow the slide here, so when I do npm run build refers to a script in my package.json, which I'm referring to up here. And the build script seems to be running something called React Scripts build, but later on we will look at React Scripts is just another third-party package that's used internally by the Create React App tool. And it's that React Scripts package, it uses Webpack. So there's kind of two levels of separation from Create React App and Webpack. So eventually we get to this Webpack tool that is being used behind the scenes. And what the Webpack tool does for this particular execution is, on the left here, it creates a build folder And inside that build folder, it will put a static version of your React app code. And I'm highlighting one particular file here. So it turns out that in this particular example anyway, all of the source code that you have written will be condensed into one JavaScript file. And it is this JavaScript file, that's what's actually downloaded to the browser and what the browser executes. The browser never sees your source code. Okay, so Webpack is being used behind the scenes. That's kind of the message I'm getting across in this slide. And when we create that build folder, so if I go back again, so this now I'm describing this here now as a static version of your React app. So how do we actually execute that static version, if you like? Well, to execute it, you need to install a HTTP web server. Any web server will do. There is a HTTP web server called the Serve server. And so I've installed that on my machine. And when I run my Serve HTTP server, it's a standard HTTP server now. It's got nothing to do with React. It knows nothing about React. It's just a standard HTTP server. When I run it, and this is how I run it, in the case of the Serve server, then I'm pointing it at my build folder. And I'm also telling it that I want it to start up on port 3000. And so, okay, the server starts up, and it's kind of now looking at this build folder, or it's making this build folder available to anybody that happens to navigate to localhost 3000. And again, if I just flip back for 1 second, if you look inside the build folder here, there is one HTML file, which is this one, index.html. It's the only HTML file. But I can tell you that if you looked inside that HTML file, there's very little in there, but it does refer to this script. So ultimately, this script is executed by the browser. And I've already told you that this JavaScript file contains all of your React application, all bundled into one file. And so when I start up my server on port 3000, and I'm pointed at that, and then behind, I'm just navigating to localhost 3000, and indeed it does serve up my Movies app for me. Okay, so that's kind of all by way of what's going on behind the scenes. So let's talk a little bit about Webpack generally. And what is it? I'm saying it's a module bundler. So it bundles or packages all of the modules that make up your web application. It doesn't have to be a React application, but it is in our case. It bundles them all up into one static JavaScript file. And how does it actually do that? I'm saying it analyzes the dependencies of your web application. So in the case of the Movies app, it would look at the index.js file at the top level of your SRC folder. And that index.js file will have a number of import statements, and it essentially follows those import statements to find the dependencies that index.js has. And some of the imports that it will be importing will be third-party libraries, but some of them will be your own component code. And inside those component code files, they have import statements as well. And we would classify those as dependencies of the component. So essentially what Webpack does is it follows the dependency hierarchy that makes up your entire React application, starting with the kind of index.js at the very top of your module dependency graph. So it can follow all of those import statements, including the import statements for third-party libraries like React itself and Material UI and all the other third-party libraries that you've used. And it essentially brings all of the code together that makes up all of the dependencies within your overall application. And it does some processing of them, and eventually it finishes up by bringing it all together into one JS file. Okay, so that's why I'm saying it bundles, if you like, it bundles all of the modules that make up your application into one unit. And how does it do that? It does it by following the dependencies of your code. Now, a module is actually not just a JS file. It also understands CSS files. They're considered modules as well within your React application. Or if you had static image files, they would be part of it as well. Not the image files now that you download from TMDB. They're not static image files. But if you happen to have, I guess if I go back for a second, you know, the image file that you use for this card here on the left, that would be a static image file. That's considered a module as well. And even if you had your own unique font files, they're all categorized as modules from Webpack's point of view. So it understands more than just JavaScript. It understands CSS and et cetera, et cetera. And I'm saying it follows the dependencies, and it understands the different ways that you might express dependencies in your code. So the one that you're using is the import statement, but there are other ways of expressing dependency relationships. The common JS way is using the require statements. I don't think you use the require statement at any stage in your coding. It's probably more old-fashioned now, really. Import is used everywhere within JavaScript. So it performs bundling predominantly. Okay, so Webpack and what Webpack does, and as I kind of already mentioned, is it generates a set of static assets. And we refer to these static assets as bundles, or chunks are also referred to as well. Okay, ideally, it's really geared towards very large web applications. Now, trying to be insulting, but I would guess the Movies app wouldn't be considered a big application, but we can still use the notion of Webpack and bundling for it. And so this is a visual representation of what Webpack does. So on the left, we have all of the modules that make up our application. Starting at the top in our case is the index.js, as I said, the index.js in the source folder. And it follows the dependency relationships to bring together. It kind of builds this internal representation of the module graph, dependency graph that makes up your application. And it generates on the output side, it generates a bundle or bundles. It can actually generate more than one bundle. But if it's just, in this case, let's say it's just one bundle. And this bundle would contain all of our JavaScript code. And even if one of these files was a CSS file, that CSS code could be in here as well. So this is what we might refer to as the bundling aspect of Webpack. It can actually generate more than one bundle. So for very large applications, maybe you don't want to bundle all of the JavaScript into one bundle. Maybe you want to break it up into 2, 3, or 4 bundles. Well, there's ways of doing that, and we'll see how to do it later on in this lecture. Also, maybe you might want to put all of the CSS, if you've got a lot of custom CSS in your if you've got a lot of custom CSS over here, you might say, well, I put all of the CSS into one bundle on its own. And equally, if you had a lot of static images, you might create a separate bundle with just containing the images. So either it's up to you how you want the output to be generated. You configure Webpack accordingly. So again, it can generate a number of chunks or bundles, as they're called. Also, what I'm indicating here on the left, if you look, so it seems like this is a JavaScript file. This is another JavaScript file. This is a CoffeeScript file. I don't know if you've ever heard of CoffeeScript. CoffeeScript can be compiled down into JavaScript. It's a much more compact language than JavaScript. Very popular a number of years ago, probably less popular now. What else? We have a CSS file and so on and so forth. So you can have different module types over here. As long as they're all can be converted back to either JavaScript or CSS, then they're understood by Webpack, and they can be converted and included in a bundle or chunk on the right. So again, kind of repeating, but on this slide, I'm saying that Create React App, it uses a package called React Scripts, and the React Scripts, it uses the Webpack internally. And so what else am I showing you here? What am I showing you? Let's see. Oh yeah, when we run npm run build, I've kind of already indicated that earlier on. When we run that command, that executes this script within your package.json. And over here on the left, then in this case, we've got a couple of bundles. We've got maybe a CSS and a JS bundle. Okay, I'm going to move on from that one. All right. Now, even though you're not going to be using Webpack directly, you're using it indirectly, it's still beneficial, I think, to have an understanding of some of the basic concepts that Webpack uses. So the first thing is this notion of the entry point within your code base. The entry point is, I'm saying, the first JS module executed when your application is loaded into the browser. And in the case of your code anyway, that is the src/index.js file. That's the kind of starting point, or to use Webpack terms, that's the entry point for your application. And you've got to tell Webpack what is the entry point for your application. Now, the React Scripts does that for us behind the scenes, but you do have to tell it anyway. What is the entry point? And all other dependencies are analyzed from that entry point downwards. The analysis of the import statements, essentially, but Webpack does that for you. Then we have the notion of loaders. And what loaders are is they perform transformations of your module's code. Now, so they're kind of, they process the modules as they're being put into a bundle. So for example, if you write ES6 or ES7 or ES8 JavaScript, that has to be converted into ES5 JavaScript for browsers to be able to execute it. Now you might, it's really nice for us to write modern JavaScript, modern being ES6 and beyond. But at the end of the day, browsers today anyway, lots of browsers, certainly old browsers, they can only execute ES5 JavaScript. So all of our modern JavaScript code has to be transformed or converted back to ES5, but Webpack will do that for us. So that's one example of what a loader might do. Also, you might have loaders that convert JSX back to ES5. JSX is very much a React thing. Browsers don't understand JSX syntax. That has to be converted back to ES5, but there is a loader that you can configure in your Webpack to do that for you. Similarly, you might, if you write a lot of custom CSS, you might like to write it in Sass, but again, browsers don't understand Sass. That has to be converted into CSS or transformed into CSS. So these are examples of the transformations that Webpack will do for us as part of the bundling process. So if I go back a few slides, so the modules that you have here, they may need to be transformed before they can be put into a bundle. But as long as you tell Webpack to do that, then it'll do it for you. And thirdly, then, well, like any tool, really, there is the notion of plugins, and there's quite a large ecosystem of plugins out there now. And plugins, like all plugins do, the plugins extend the core functionality of a tool. The core functionality of Webpack is looking at the dependency graph that make up your application and creating bundles. And thirdly, transforming your source code into a form that browsers can understand. They are the core tasks of Webpack, but you might want to extend what Webpack does beyond that. And there are plugins that will usually out there that will do that for you. What I'm mentioning here. Okay, that's okay. Move on from there. Now, Webpack is a tool, so we need to configure it, or it needs to be configured. There are 3 ways that you can configure Webpack. You can do it from the command line. You can do it by writing your own Webpack, by writing a script that actually uses the Webpack API. That would be for very sophisticated use cases. The third option, which is by far and away the most common one, is to use a configuration file. And the configuration file has a prescribed name, so it's webpack.config.js. So you've got to create this. If you want to use Webpack directly, you've got to create a file, call this, put it into your project's base folder. And then when you run Webpack, the Webpack tool itself, it will automatically go looking for that file. And this is the file that tells us what loaders are you using, what is the entry point in your code, what extra plugins should it use, etc., etc. By the way, it is a configuration file, but it's actually a JavaScript file. It's not a JS file. We won't be writing any webpack.config.js directly, but there is one there that we are using. And that's actually what I'm showing you in this screenshot here. So if you actually opened up the Node modules folder in your current Movies app, and if you scroll down and find a third-party package called React Scripts, and if you open up that subfolder, so we're now looking at the React Scripts package that the Create React App tool uses. And lo and behold, inside in a subfolder within that, let's see. Yeah, inside in the React Scripts package, there is a subfolder called Webpack. Let me see. Yeah, called. Sorry, it's not inside in the subfolder. It's actually in the React Scripts folder itself. Webpack.config. So this is a Webpack configuration file that is already available to you, and it's here down inside in the React Scripts package itself. And if we look inside that file, which we don't need to do, but it is a Webpack configuration file. So that's the one that we are actually using anytime we run npm run build for our Movies app. That's the Webpack configuration that's actually being used behind the scenes. And you never need to go near it really and make changes to it. Now, another aspect of this whole bundling process is the notion of source maps. And I'm saying source maps are generated during the bundling stage. So when we run npm run build for our, let's say, our Movies app, I've already showed you that it creates this build subfolder. And if you looked closely inside it, if you opened up the statics, let's see here on the right, I'm kind of showing you on the right, if I just zoom in a little bit. So this is actually from the Movies app itself, and I'm inside in the build folder, and within the build folder, there's a subfolder called static. And within that, there is a subfolder called JS. And here is, in this case, there's only one bundle file. So this is the actual file that contains all of the Movies app code, which has been transformed. All the JSX has been transformed into ES5, and any ES6 plus code that you've written has been transformed as well. So that's our bundle. There's only one bundle in our case, but there's another file here that has a similar name to it, but it ends in .map. Sorry, where is it? There it is there. Okay. That's what we call a source map file. Now, what is the purpose of that source map file? It's generated for you. And what it does essentially is it maps a line of code from a bundle file back to your source code file. And why is that of any use to us? Well, you see, if we didn't have our source map files, when we run our React application inside in the browser, and let's say there's a bug in it, and we can look at the bug from within the developer tools of your Chrome browser, let's say, then you might get an error message like this. But what it's giving us here is the line number where the error occurred, but it's the line number within our bundle file. And the bundle file really doesn't make any sense to us. What we want to know is, what is the equivalence, or what line from the bundle file does this map back to in our source code file? So what we'd like to get is something like this. Okay, and we can now make sense of the error because we're told exactly it's inside your homepage.js file. It's line 75, and that's the actual error. So we can look at our source code and try and do our debugging from there. This message up here really doesn't make any sense. Now, the way we actually can get the browser to give us these kind of error messages is because of these source map files. And the source maps are downloaded to the browser with your bundles. So the browser can actually make sense of these maps. Beyond that, we don't need to worry about the internals of these map files. We just need to be aware of what their role is. And we don't even care about how they're generated either, because Webpack does that for us. But just on that point of how do you generate source maps, there are different, let's say, levels that you can ask whatever the build tool that you're using is. You can ask it to generate source maps such that they generate what I'm called fully featured source maps. Let's see, and keep them separate from the bundle files itself. And that's what we actually saw on the previous slide. So the source map is a separate file from your bundle file. You would typically want that in a production environment. But in a development environment, maybe you're okay with having the source map data included in the bundle file itself. And so this option here would give you that. Okay, so you're telling the bundler tool to include the maps in the actual bundle files. Now that clearly makes your bundle files very big and slow to download to your browser, but that's okay maybe in a development environment, but it wouldn't be okay in a production environment. Anyway, that's just, by the way, we'll never be switching between these two anyway. I've already mentioned loaders as being an important core part of the Webpack tool, and indeed of bundling in general. So I'm saying Webpack out of the box kind of works. It understands ES5 and ES6, but the problem is that older browsers, they only understand ES5. So the common denominator is ES5, ECMAScript 5. The only JavaScript web applications that we write, ultimately we have to convert it back to ES5 so that every browser can actually execute it. And that's what the loader does for us. Well, loader is plural. So loaders extend, that's okay. They apply transformations. I've kind of already said that, so I've made this point as well. So you might like writing ES7 or ES8 code. You might even like writing CoffeeScript, which is a cleaner form of JavaScript, or a more up-to-date comment would be you might prefer to write your code in TypeScript rather than JavaScript, but equally browsers don't understand TypeScript, so that has to be transformed back to ES5 JavaScript. And that's what the loaders will do first, but it's loaders plural. So you could actually, there's nothing stopping you from writing some of your source code within one application, some of the source code written in TypeScript, some of it written in CoffeeScript, some of it written in ES7. You have a mixture of all of those within one application. But it just means you need to have a separate loader configured in your Webpack configuration to do the transformations for you, and then Webpack will do the rest. And these various loaders, what they are, the way they actually work is they're bound to, or they look for files with a particular extension, file extension. And that's how Webpack knows which loader should it use to carry out a transformation. And the file extensions are fairly standard. So it's obviously .js for JavaScript, plain JavaScript. I think it's .cs for CoffeeScript. It's .ts for TypeScript. You could use other file extensions, but you need to tell Webpack if you're using a specific file extension for one of these variations on JavaScript. But that's how the loaders work anyway. They look at the file extension for a particular module, and then that tells it what loader should it use to carry out the transformation before it puts the output of the transformation into your bundle. Loaders are just npm packages, and if you really dug deep into your node modules for your movies app, then you would find packages in there that are actually Webpack loader packages themselves. Similarly, plugins come in the form of just npm packages. So this is all by way of background, admittedly. But sometimes it's important to know what's going on behind the scenes, even though you're not using it directly. I'm saying here that Webpack goes beyond just basic JavaScript. So it can treat every type of file as a module. I've kind of mentioned that really earlier on as well. So CSS, Webpack understands CSS, and it understands if you've got an import statement within a CSS file that refers to another CSS file, in other words, that's a dependency relationship, but it's able to follow those dependency relationships as well. It understands font files and image files, and it can follow various dependency indicators. So this, I think, is a CSS dependency directive, and you can use URLs as well if you're referring to CSS files by means of a URL. It understands that those types of dependency indicators. You can embed, it can embed your CSS into your JavaScript bundle. So a bundle file, you can't really tell necessarily just because the bundle file ends in .js. It may also contain CSS embedded within it. And that's something that you have control over by means of the Webpack configuration. But certainly for large applications, you would tend to have a separate bundle that contains just the CSS code. Equally, if we can include images as part of our bundling, then where do the images go? Well, you can put the images, include them in your JS bundles, if there are very few of them. If there are a large number of static images, then you can ask Webpack to create a separate bundle with just the image, the static image assets. And that's why you've got this kind of option here, as I've talked about already. Well, I don't think there's anything particularly new in this slide for ye. Maybe I should have taken it out really, but because this is the only way that ye are expressing import statements in any of your code. The old way of referring to dependencies was using the require statement. You may still see that statement used in blog articles that you read on, but they would tend to be quite old articles, admittedly. In terms of CSS, as I've kind of already mentioned, you can have import statements in CSS files as well, which you probably know. And what I'm actually getting at here is that inside in a JavaScript file, you can have an import statement that refers to a CSS file. Yeah. And then that allows you to use whatever CSS rules you have defined in the CSS file, use that within your JavaScript code. So maybe, we could use any CSS rules in our JSX if we wanted to, if we were importing this Bootstrap CSS file. But it's just another dependency relationship. And just because it's going from a JavaScript to a CSS, that doesn't bother Webpack. Plugins, I'm going to quickly maybe move on from that. They are just separate third-party libraries. They can be used for lots of things. These are just a small example, 2 examples of plugins that pretty much every Webpack configuration uses. There's this one. This is the plugin that every time you rebuild your application, your web application, it will just clean out the build folder, essentially delete the build folder in preparation for the new build, which is a fairly standard thing that you'd want to do. But unless you use this plugin, then you're going to have to put that instruction somehow within your Webpack configuration. But you don't have to. Just include this plugin and the plugin does that for you. This plugin is the one that generates the index.html in your build folder. Yeah, maybe I'll come back to that a little bit later on. Now, when you are bundling or building your web application for production use, then a key concern is this load time performance of your web application. And the load time performance is how long does it take between the time the user kind of enters the URL for, let's assuming your web application is deployed onto some server, so it's accessible by anybody. How long does it take between the time the user enters the URL of your web application into their web browser and they see the actual rendering of the web application in the browser? That initial load time has to be really quick, otherwise users kind of get bored and they move away from your application. So the load time performance of your web application, the initial load time performance, is a key quality aspect that you need to be concerned with as a developer. And there are some standard techniques that you can use, and these kind of relate to bundling now. These are standard techniques that you can use to decrease the load time or improve the load time performance by decreasing the load time. So there's minification and uglification, caching, and code splitting. The first 2 are actually, you get kind of for free with Webpack. It performs minification and uglification, and it also supports caching, as we'll see in a minute. Minification is essentially, you see inside in the build, let's see, maybe I think I have a screenshot of it in a minute. Code splitting, if I just move on, code splitting is something that you control at the source code level. So we need to see how do we actually achieve code splitting for our React app. The other two, as I said, kind of come for free with Webpack, but we still need to be aware of them. So these techniques for improving your load time performance, these are kind of collectively referred to as optimizing your web app bundling. And surprise, surprise, they certainly the minification and uglification, they are performed by, in the case of Webpack anyway, they are performed by plugins, and I'm mentioning one here. This is another plugin. What does this one do? It creates a separate CSS bundle. Oh yeah. So this one creates a separate CSS bundle from your JavaScript. That's probably a good idea. The JavaScript can download first, it can execute, and while it's executing, the CSS can be transmitted across the network. So it's probably a good idea to keep your CSS separate from your JavaScript from a bundling point of view. Yeah, this is the screenshot here that I'm showing you. I've actually opened up the bundle file that was generated by Webpack for me. And obviously it's completely unreadable, but it is JavaScript code. And just to prove that it is the JavaScript code for my movies app, I just did a search of the word movie, and I found a number of hits, obviously, given the context for this application. So it does look like it is actually our movies app that has been minified or compressed, essentially all the white space. There's no indentation and alignment. That doesn't really make any use or make any sense from a browser's point of view. It doesn't care about indentation and alignment in your code. We care about it a lot in our source code because it makes our code more readable, but a browser doesn't really care about it. So there's no white space in the bundled file that Webpack has generated. That's minification. Uglification is, whereas we like to use meaningful variable names, and sometimes the variable names can be quite long. That makes sense from a source code point of view, again, because it makes our code more readable. But long, meaningful variable names doesn't make any sense from the browser's point of view. It doesn't care about that. So, and similarly for component names and function names, it may actually change the names of various variables that you have in your source code, change them into something far shorter, like XYZ, and just use that consistently throughout. Of course, the source maps will map the compressed or uglified variable names back to your source code names. So that's what uglification is. It's essentially changing the names for the various entities that make up your application into more shorter kind of succinct names. So that's minification stroke uglification. The other technique I mentioned, the second technique I mentioned was caching. I guess we're familiar with the notion of caching. And caching is a big part of how the internet works, because various devices that make up the internet can perform and support caching, and I'm just mentioning him here. We're particularly interested in the web browser and getting the web browser to cache assets so that they don't have to be re-downloaded every time you want to look at a particular page in your browser. Now, does Webpack support caching? And if so, how does it do it? Or what does it do to enable our web browser to perform caching? Because caching is built into the way the browser works. But if we are writing web applications that don't support it in some way, then the browser can't avail of it. So in the case of Webpack, it leverages caching to the file naming convention that it uses for your bundle files. And what it does is it computes the name for a bundle file as a hash value of the file's content. So if I just flip over to VS Code, I've got a little sample application here, which I'll talk about eventually. It looks like it'll be tomorrow now before I get to talk to you about it. But it's a React application with some components and some 1 or 2 pages. And I've built it. Let's build it here again, actually. And if I look inside my build folder and inside the static and JS, now I have 2 bundles in this case. I've got a separate CSS bundle. But if you look at here's the one and only bundle file that makes up my application. But the file name, it has a name part, and because there's only one bundle, the name part is just main. That's just a convention that Webpack uses. This part here is a hash that has been computed by Webpack, and it's a hash that has been computed based on the contents of the actual file. So it does reflect the contents, the hash value, and the extension is .js. So that's what I mean by hash-based file naming convention. Now, how does that actually relate to this area of caching? Well, let's go back here. Sorry. I should also say as well, here's the index.html that Webpack produced. And if I open up that, that's also in a kind of compressed. Is there anything there? Oh yeah, it's in a compressed form. But if I just do a little bit of reformatting to make it a little bit more legible. Let's see. Don't do this. All right, just give me a sec. Oh yeah, here we go. Here's it formatted, and there's very little in it, but in particular, there is a script tag here. And surprise, surprise, the script tag is referring to the bundle file itself. And Webpack actually produced this index.html. So every time I load this application into a browser, this index.html file is going to be loaded into the browser first, and then the script tag will cause the browser to now go back to the server and ask it for the particular script file. And if I'll finish on this point now. So let's follow that through. So here I'm showing a communication between a browser and the server that's notionally hosting my React application, or any web application really. So the user enters the URL of the application into the browser. That causes the browser to request the index.html. Let's supposing this is the domain name that it's being hosted to. So the index.html is returned back to the browser. And inside the index.html, there's a reference to the bundle file. And so that causes the browser to now request the bundle. And I'm just using a bundle 1234 here as being my bundle file name. So that's like the main dot hash value.js from previously. So it requests the bundle file, and the bundle file is sent back to the browser. And now the browser executes the bundle file, and it renders the home page to the user, and the user plays away with the application. Now, let's supposing later on could be anything really, later on that day or whatever, the user browses to the same web application. So the request again goes to the backend, and the index.html is sent back. Now, do I have a comment there? Sorry, okay, yeah. So the index.html is sent back. Now, what the browser will do is it will notice that there is a reference to a bundle file, but because it has cached the bundle and the name of the bundle file is the same as before, and it will probably have cached it using the name of the file as the key in the cache. It now knows I don't have to request the bundle file because I already have it in my cache, and it will render the page to the user, and the user plays away with the application. Sometime later on, let's say we make changes to the source code. The developer makes changes to the source code of the application and rebundles it, in which case the bundle file is now going to have a different name. That now means when the user navigates to this particular web application, they get back the index.html as before, but now the index.html is referring to a bundle file that the browser hasn't cached from previously because the file has a different name. And in this case, it will request the actual bundle file and it'll be returned back, and it'll cache it again. So up until this happened, every time the user navigated to this application, the bundle file didn't have to be downloaded from the server. And that's the benefit of caching. That means that the load time for the application is much quicker after the first loading, if you like. But browsers will just do the caching for us, okay? We don't have to do anything. And as I've already said, Webpack supports browser caching by virtue of how it names the bundle file. And okay, maybe it's clear to you now, but it's not until the developers make changes to the source code and rebuild the application that now means that the bundle file essentially has a different name. Right. So that's fine. That's caching taken care of, and Webpack does it for us. The last aspect is code splitting, and this is where I'm going to have to pick up the story from tomorrow. So yet again now, for the first hour, I'd say at most really, of tomorrow's 3-hour lab session, I will deal with this topic here, because this is something that we control as developers, and we have to actually put some code into our source code to enable code splitting to actually happen. And I'll also explain what I mean by code splitting. So I'm going to pause it there for today, and well, there's hardly time for questions now, but if you have questions, you can put them to me tomorrow's lecture come lab. Okay, I'll leave it at that for now.
Sure. Jeremy, just one small question regarding the assignment. I see that like in the tool chain, it says that we have to use the continuous integration for GitLab. I've never used GitLab before. Are we going to get a lab on it, or?
Yep, that's tomorrow's lab.
Tomorrow's lab, okay.
This week's lab is all about GitLab, and you'll essentially be able to, when you've completed the lab, you will be able to reuse the YAML file, if you can remember from the lecture from 2 weeks ago. You'll be able to reuse that YAML file in your assignment. That's the way I've kind of structured it. So
yeah, so after the lab tomorrow, like we'll be able to start our project, right? Or our assignment.
Yeah, but I mean, I'm sure you wouldn't necessarily have been working it over the midterm anyway, but a lot of what the assignment is about is Cypress testing or end-to-end testing using Cypress. And you can do all of that stuff before you ever go near GitLab. And in fact, I'd probably encourage you to write some Cypress code and just run the Cypress code locally before you ever start building your continuous integration pipeline. That would be my advice. But
okay,
yeah, and this, of course, you know that this kind of runs in parallel with, has Roseanne given you a specification for her assignment?
Yes, she's given us a few specifications.
Yeah, okay, so it's the functionality that you will develop for her assignment, that what you will be spending a lot of your time writing tests for my assignment, as well as maybe some tests that I didn't cover in the Cypress lab for the functionality that she would have developed in her labs. There's some aspects of it, like reviews, movie reviews. I didn't give you any Cypress tests for exercising the movie reviews part. You could write tests for that as well.
Okay.
Great. So I'll talk to you tomorrow.
All right. Thank you.
Bye bye.
Thank you.